Hello, I'm Faith Rogers, host of today's program, COVID-19, Keeping Up with the Moving Target. Thank you for joining us. This activity is jointly provided by the Postgraduate Institute for Medicine, DKB Med, and the Institute for Johns Hopkins Nursing. Today's program is accredited for ANCC, AAPA, and AMA-PRA Category 1 credits. Please visit our website for complete CE information. If you're tuning into our webcast, please click the Claim Credit button on the webinar console. Otherwise, please go to covid19.dkbmed.com, navigate to our multi-specialty episodes, and select the webinar to claim credit. Today's learning objective is to discuss the current trend in influenza, COVID-19, and RSV activity. This educational activity is supported by independent medical educational grants from Gilead Sciences Incorporated, as well as in-kind support from DKB Med. With us today, we have Dr. Paul Auwaerter, Clinical Director of the Division of Infectious Diseases at Johns Hopkins School of Medicine. Dr. Auwaerter, thank you so much for your time today.
Thank you, Faith. Today in this program, what I'd like to do is reflect a bit on where we are with this respiratory season. This has been maybe the same but different compared to pre-pandemic respiratory seasons. We have influenza, we have respiratory syncytial virus, and then, of course, the SARS-CoV-2 continues to be with us to a degree that's probably advancing more serious illness in patients than the other two, but all three are certainly playing roles. And I think this will be likely the new normal. But the pandemic story has not completely ended, but it is changing, and perhaps for the better, despite continued changes that do require us to rethink some of our patients' care. In terms of the subvariants, if we just look at more of a real-time picture, you can see in the pink-red curves up top, at least towards the end of 2022 and now in January, the number of newly reported cases have declined, but of course, many people are doing home antigen tests, or they're not even being tested at all. So the real numbers are not exactly clear. And the testing positivity of people who are being tested remains extraordinarily high at 11%, which to me means that community levels are far greater than what these actual reported cases reflect. But more encouraging are the gray graphs of hospitalized and deaths, where compared to the original Omicron wave a year ago, and even this past summer, it's blunted in terms of the people landing in the hospital or unfortunately succumbing, although the numbers remain substantial, as you can see in this past week, with perhaps 500 people a day dying, which of course is still too many. Now, part of the issue is the ongoing story of Omicron subvariants that continue to evolve rapidly. The latest kid on the block is XBB, which quickly turned into XBB15. In the press, you may have heard this term, the Kraken. This is actually a hybrid of two earlier Omicron subvariants, and it contributes really to immune evasiveness due to earlier infection-acquired immunity or ancestral strains that led to our current mRNA vaccines. It's been widely reported that at least in the Northeast US, over 80% of infections are now this new subvariant. And you can see in this graphic feature from the CDC, which was really now 3 weeks old, accounted for a quick increase, really faster than any other subvariant. And by their modeling is becoming predominant. Now, I want to just emphasize, because it won't be elsewhere in the program, that if you've had the new bivalent mRNA vaccine booster, this does give protection against severe infection. And if you've not had that and you are certainly in older ages, over 50, or have health problems, I would recommend it. So this current subvariant contains a mutation in the spike protein that enhances its binding to cell receptors. That's the ACE2 receptor. And this probably means you're generating high viral levels and facilitates transmission. Data seems to suggest that the so-called reproduction number is now 1.8, when the earlier common variant BA.2 was much lower at 1.2. So this gives you an idea of why we're seeing more cases, and probably many of your friends, neighbor, workplace colleagues have developed infection. Now, it doesn't look like it's especially more virulent. And of course, many people already have some degree of existing immunity. But why is it perhaps not as virulent? And for those that want to know, we have been focusing so much on the spike protein because that's what's been key in terms of providing protection by the vaccine, and also important for avoiding severe infection. But other mutations in the BA1 variant for which the current subvariants have evolved are that there's actually another critical protein called the non-structural protein 6 that actually works inside host cells in terms of assembling lipids needed to make new virus. And so this mutation, if you reverse it in animal models, makes the virus more like the earlier viruses, such as alpha or the ancestral strain or even delta, in terms of its ability to sicken mice. So this is an indication that there are some other mutations which is adapting here, because if you're a successful virus, you want to actually infect a lot of people and not kill them, because that's, or make them very ill, taking them out of circulation, and become perhaps more like the common cold coronaviruses, of which we have 4. But this virus continues to evolve, so we'll just have to wait and see. A couple of other points that I thought worthy of discussion were the effect of the most recommended drug for COVID at the moment, and that's nirmatrelvir-ritonavir by the trade name Paxlovid. And of course, this was studied in unimmunized populations and helped avoid death or hospitalization in 28 days. But what we don't know now is how helpful is it in this current era where people have been immunized or have had infection-acquired immunity. And this large study from New England was published recently in the Annals of Internal Medicine. And it's a population-based study, which is going to be retrospective and subject to all sorts of bias, potentially. But what you can see here is that if you didn't get Paxlovid, there is about a 1% overall risk of landing in the hospital or dying. And that lowered to by about 45%. If you took Paxlovid, and you can see there, of course, protection against death, which was much less frequent, was more significant. But to give you an idea of the impact, the number needed to treat to avoid one of these outcomes is over 200 by just very rough calculations using these numbers. So obviously, lots of people will do okay without it. But we'll talk a little more about perhaps how one might decide whether to give someone Paxlovid. Now, the rest of the respiratory season, of course, includes seasonal influenza. That's with us. We saw none 2 years ago. We saw more last year. And this year, it's come back with more force and in a typical fashion. So we not only had COVID, now we have influenza, and we saw a very classic peak after the Thanksgiving holidays in December through early January, although numbers are declining and certainly landing people in the hospital, also with some reports of co-infection of influenza and SARS-CoV-2. And then lastly, earlier in the fall, respiratory syncytial virus was in the news. And this really was a fierce season, probably because so many had been children either had been born and kept out of community circulation with social mitigation factors and so on, had an extremely robust RSV season very early, pediatric emergency rooms and ICUs and hospitals were overwhelmed, but this has declined as RSV will, and probably even sharper decline, thankfully, before influenza and SARS-CoV-2 came over. But of course, also people over 65 are at risk. It's not just younger children, those under 2 historically, but because many children had never been exposed, those 5 and under were particularly prone this year. So I think we're seeing, again, all the major viruses. Of course, there's many more, but RSV, influenza, and now SARS-CoV-2 are the 3 that often might land either children or adults in the hospital. And this may well be our new normal.
Thank you very much, Dr. Auwaerter. And we do have one learner question today, which is, how do you decide whether to treat a patient for COVID-19?
Yeah, this is a very good question, and why I think I put up that population-based study using the protease inhibitor against SARS-CoV-2. Currently, by emergency use authorization for Paxlovid, you have to be at high risk for COVID-19 and have less than 5 days of symptoms. But if you're over 50, or you might be just a little overweight, BMI maybe of 26 or 27 and otherwise healthy, but you're immunized and boosted, it's not clear you're probably going to benefit very much from the drug. And certainly prospective trials have shown those under 50 don't have any benefit in terms of avoiding severe COVID-19 because probably your risks are so very low. Where I get more concerned are my patients over 65, certainly over 75, and definitely over 80, 85, and especially if they have 2 or 3 comorbidities, where I really will talk to them about taking the drug. Many of my patients have not wanted to take it because they've heard stories of Paxlovid rebound. They don't want to isolate extra, but that minor inconvenience pales, I think, even though risks are relatively low, to avoid landing in the hospital or dying. So I'm a strong believer still in the drug, even in those people that are immunized and boosted, depending on their age and comorbidities. Now, of course, many people are diagnosed by a home COVID test. And so if one is negative, I'll usually have them repeat a test in 24 hours, 12 or 24 hours. Also, influenza is circulating. We don't have a lot of home influenza tests available at the moment. So that might even tell me that someone's over 65 or have significant health problems. I might be prescribing oseltamivir or baloxavir empirically there, pending a follow-up COVID test. So this is something that I think you can make a judgment. People that are solid organ transplants, people because of drug interactions that can't take Paxlovid. We no longer have monoclonal antibodies. So there, I really have to weigh, especially for people with B-cell disorders or not responding to vaccines, about 3 days of remdesivir at an infusion center. And of course, molnupiravir is on the menu, but it's probably less effective, but I prescribe that more than ever since December. For patients at risk that might not be able to travel to get remdesivir but are at high risk, or those that just simply don't want to deal with 3 days of infusions. So I thank you very much for a question. That's it in a nutshell. And of course, with a wide range of latitude and clinical judgment that go into these discussions and shared decision-making with your patient.
Great information as always. Thank you again. If you're tuning into our webcast, please click the Claim Credit button in the webinar console to attest for credit. Otherwise, please visit us at covid19.dkbmed.com. Again, thank you for joining us, and thank you for your dedication to your patients with COVID-19. Thanks again, Dr. Auwaerter.
Thank you, Faith, and hope the respiratory season continues to tail off through the winter without more surprises. Take care.